Okay, so this is question 7 from the 2023 Higher Level Maths Leaving Cert paper 2. So Olga is a cyclist. The diagram below shows the road AB, which is not to scale. AC is horizontal, so AC is along here, and BC is vertical. BC is 9 meters and AB is 70. The gradient of the road AB is BC over AC, so the tan of this angle here, written as a percentage. So let's see what we have to do. We have to find the gradient of AB correct to the nearest percent. Okay, so let's do that. Now we've got to do 9, which is BC over AC. We don't have AC, so we've got to do Pythagoras' theorem. So it's going to be, let's see, AC. The distance from A to C is going to be the square root of 70 squared minus 9 squared. This is just Pythagoras' theorem. I skipped a few steps, but that's it there. And you get the square root of 4819 when you do this bit here. So AC is the square root of 4819. So we got to find the gradient then. So the gradient of AB is just going to be 9 over the square root of 4819 times 100, which is to the nearest percent, 13%. Give your answer correct to the nearest percent, and that's it there. There's my answer. Okay, next one, part B. Olga wants to measure the vertical height of a hill. The point H is the top of the hill. The points O and P, these two here, are 20 meters apart on horizontal ground at a point bottom of the hill. Olga measures the angle of elevation from O to H as 17 degrees here, I see, taking O as being the point directly below H that is horizontal with O and P. Olga also measures the angles OPR and ORP, these two angles here, we have those. All of these are shown in the diagram below, not the scale. Work out the distance OH, so you got to work out this distance here, the vertical height of the top of the hill relative to the points O and P. Give your answer correct to the nearest meter. Okay, so what we're going to have to do here first is work out this distance here, the distance from O to O. So the distance from O to O we can work out using the sine rule. We have two angles here. We need to work out this angle, but that's easy enough. Then we have one side, so that's perfect. We can use the sine rule, we can find this, and then we're going to use tan 17 to work out OH. So let's do all of that. So first thing I'm going to do is just work out this here. So the angle, let's see, the angle OP is going to be 180 degrees minus 88 degrees minus 87 degrees. When you do all of that, you get 5 degrees. So this angle here is 5 degrees. Now we're going to use the sine rule. So I'm going to say the sine of 5 degrees over 20 is going to be equal to the sine of 87 degrees over the distance from O to O. So we can cross multiply here and then divide, so we get the distance from O to O is going to be equal to 20 sine 87 divided by sine of 5 degrees. And when you do that, you get the distance from O to O as 229.1597784 and so on. So we have this distance along here now. So that's 229.1597784. So now all we've got to do is use tan of the angle 17. So let's do that. So we want tan 17 degrees is going to be equal to the distance from O to H divided by 229.1597784. Don't need that many decimal places, but anyway. So that will just give us OH the distance from O to H, which is what we're looking for. Just multiply across by this 229 here. So tan 17 times 229, and that gives you 70 meters. Give your answer correct to the nearest meter. So that's to the nearest meter. So let's move on to the next question then. Down here, let's see, we have Olga has done some measurements. She's measuring her lung capacity. When she is resting, the volume of air V in her lungs after t seconds can be modeled by V of t is equal to 2 minus 0.4 cos pi over 2 times t. V is in liters, so the volume is in liters. Time is measured in seconds, and it's always going to be positive or zero from a given point in time. Pi over 2t is measured in radians, so you got to make sure that you change your calculator to radians. The diagram below shows the graph of the function y is equal to v of t for the first 9 seconds. Now we have volume on the y-axis and time on the x-axis. Find the values marked a and b on the graph, the minimum maximum values of v. So you got to find these two values here. We can do this a couple of ways. So if you take a basic cosine graph, it's going to look like this. And it's going to go from -1 to 1 here. We have a minus cos here, so that's just going to flip it upside down. So it's going to be the same thing again. We're going to start here, we're going to go up here, and we're going to finish down here. So again, this is -1 to 1. However, what we've done here is multiplied by 0.4. So what that's going to do is change the range. So this is going to be minus 0.4 here, this is going to be plus 0.4 here. Now the next thing we're going to do is move the entire graph up 2 places. So I'm not really worried about the period for the moment, by the way, so I'm not looking at this part of our function. So let's move the whole thing up 2. So if you take minus 0.4 and move it up 2, so you want minus 0.4 and you want to add 2, so that'll give you 1.6. So that's going to be A, if you like. So what we've done is we've taken this graph and we've moved it up. So this here is going to be 1.6. Now I just got to find this point here. So all we've got to do here now is take the 0.4 and add 2. So 0.4 add 2. So that's going to give us 2.4. This is going to be 2.4. So this is going to be A, this is going to be B. So I mean, you can do that. I mean, this is kind of a pedantic way of doing it, but really all you've got to do is take that 2 there, add the 0.4, take that 2 there, subtract the 0.4, it'll give you the same kind of answers. That's effectively what we've done here. So we got 2.4. So this is going to be 1.6, this is going to be A, and the 2.4 is going to be B. Okay, so let's move on to the next part. Oh yeah, so what is the connection between V prime T, the derivative of V, and whether Olga is breathing in or breathing out? So V dash T is the rate at which the volume of air in her lungs is changing. So if V dash T, if the derivative is positive, the volume of air V in her lungs is increasing, so she is breathing in. If V dash T is negative, the volume of air in her lungs is decreasing, so she is breathing out. That's basically it. So that's part D. Let's have a look at E then. Use the formula V of T is equal to 2 minus 0.4 cos pi over t to find each of the following when Olga is resting. Give each correct to 3 decimal places. First one, find the volume of air in Olga's lung half a second after t is equal to 0. So basically what we want here is V of 0.5, that's equal to 2 minus 0.4 cos pi over 2 times 0.5. Now you can do all this on your calculator. Again, just make sure that your calculator is in radians. We want our answer to 3 decimal places, so our answer is 1.717, and that's liters. Second one here, find the rate at which the volume of air in Olga's lungs is increasing half a second after t is equal to 0. So we've got to take our function, this function here, and we've got to differentiate it. So let's do that. So we have v prime t, that's going to be equal to, this will become 0, the minus 0.4 will remain there. Now when we differentiate cos, you get minus sign. So I have a minus sign here multiplied by minus 0.4, so this is actually plus 0.4. Now I'll have sine, and then pi over 2 times t, and because it's not cos of theta, it's cos of some function of theta, then you've got to use the chain rule. So what you've got to do is, this here is pi over 2 times t, so when you differentiate that you get pi over 2. So there's an extra pi over 2 here multiplied, so I'll put that in here at the beginning. So we're going to multiply by pi over 2. And that's it for the differentiation. So what we've got to do now is put in half a second. So we want v prime 0.5. So that's going to be pi times, well, 2 into 0.4 there is just going to be 0.2. We've got to have sine here, and then pi over 2 times 0.5. Again, make sure your calculator is in radians, and when you do that you get 0.444. Now this is a rate of change here, so this is going to be liters per second. Okay, so that's E done. Let's have a look at F. So that's over here. Olga's breathing is also measured while she is doing gentle exercise. During this time, when she breathes in fully, the volume of air in her lungs is 3.6. So that's when her lungs are full. When she breathes out fully, the volume of air in her lungs is 1.3 liters. So that's going to be our range there, I presume. She breathes in and out twice as many times per minute as when she is resting. So that's going to affect the period of the function. Use this information to write a formula for E of t. So we want E of t. The volume of air in Olga's lungs during this time, t seconds after she has breathed out fully. So our graph is going to look like this. It's going to be up here somewhere. She's breathed out fully, so she has to breathe in. So it's going to go up first and then down and then up and so on. So we've got to find this value here, and the period as well. So this value here. Okay, so let's have a go at all of that. Give your answer in the form A plus B cos CT, where A, B, and C are real, and CT is in radians. Okay, so the first thing I think I'll do is just work out the period here. The original period here is 4. So she's breathing in and out twice as fast. So it's going to be 2. The new period is going to be 2. Now remember, to work out the period of a function, you take 2 pi, you divide it by the coefficient of the angle, if you like, or in this case the variable t, I should say. So you're going to divide it by c. So in our case, our period here is going to be 2. That's the new period of the new function. So we just got to work out this coefficient here. So that'll give us 2 pi is equal to 2c, or c then is just going to be pi. So we know that our function is going to be cos of pi times t. So that's the period worked out. We just now have to work out the a and b here. Now we know it's going to be minus, because this is flipped upside down. Remember, your normal cos function will start here, go down, and then up. This one is flipped upside down, so it's going to be minus something here. Okay, so remember as well here that we're starting at -1, we're going up to +1. This is your standard cos theta function. So if we flip that upside down, what we'll get is same function again. This time it's going to start here, go up here, and then down here like this. So again, it'll still be -1 and 1 here, our range. So okay, if we take the minimum and maximum here, the range of our function, it's going to be from 3.6 to 1.3. Now, if you subtract those two, so if you take 3.6 minus 1.3, that gives you 2.3. Half that will give you the amplitude. So the amplitude is 1.15, and that in fact is going to be the B part here, 1.15. So now all we've got to do is work out what A is. So if you imagine now that our function is going to look like this now at this stage. We're starting here, up here, down here. This is our cosine function. This here is going to be -1.15, and this is going to be 1.15 here. So what we've got to do is move this up so that it is at 1.3. So we've got to add something to minus 1.15 to bring it up to 1.3. So what distance is that? We'll take 1.3, subtract minus 1.15. If you do that on your calculator, let's see, 1.3 plus 1.15, that gives you 2.45, 2.45. So that would suggest that this here is 2.45. You can check that as well by adding 2.45 to 1.15. So if we add 2.45 to this value here, do we get 3.6? So let's just check that. So 1.15 plus 2.45, and that does give us 3.6. So that's correct. So this is our answer here. So E of t is equal to 2.45 minus 1.15 cos pi of t. And that's it for this question.